So we're finishing working on geometric sequences. We've got a particular type of bacteria, divides into 2 new bacteria every 20 minutes. A scientist growing the bacteria in a laboratory begins with 200 bacteria. How many bacteria are present 4 hours later? So we have to think about our original value. At time 0, when he gets started, he's got 200 bacteria. Since we're getting 2 new bacteria, our amount is doubling. If he starts with 1, he's going to get 2 in the next time. So that's our common rate. We're doubling, so our R is 2. So our explicit function, f of n, will be our initial value, 200, times our ratio to the n, since we're starting at time 0. And our recursive, we'd say f of n is equal to our rate, 2 times f of n minus 1, or f of 0 is 200, and n is greater than or equal to 1. Well, these are changing in 20-minute increments, and we're thinking about what's happening 4 hours later. So this is happening in 20-minute increments. And so 4 hours divided by 20 minutes means we're looking at when n is 12. Since there's 3 sets of 20 minutes in an hour, 4 times 3 would be 12. So we're taking f of 12. So we'll take 200 times 2 to the 12th, which gets us to 819,200 bacteria after just 4 hours. So describe the difference between an explicit rule for a geometric sequence and a recursive rule. So again, same idea as we talked about before. Explicit, if we want to find any value or just one value. And then recursive, if we want to find all the values. How would you decide to use n equals 0 or n equals 1 as a starting value for a geometric sequence modeling a real-world situation? That's always the hardest thing to figure out. So a time-based sequence, such as bacterial growth, like we did in the last problem, typically starts with n equals 0, which corresponds at a time of 0, meaning that no time has elapsed. For something like a single elimination tournament, n equals 1 typically corresponds to the first round.